Hello students. Hello and welcome to this video. In this video, we will solve question number 36 to 40. The reason of solving only 5 problems is that 40 has 5 parts, so I don't want to solve too many problems because I know that attention span of people these days are too small. So the link to download the PDF will be in description, and at the end I will show you how you can download updated copies, and I will show you my question answer website where you can come and ask questions. So without further ado, let's get started. Question 36 says that find the middle term in the expansion of x minus 1 upon 2x raised to the power 12. So there will be 13 terms in the expansion, so 7th will be middle. And 7th term is given by 12c6 x raised to the power 6 minus 1 upon 2x raised to the power 6. So powers of x will cancel out and we will have 12c6 1 upon 2 raised to the power 6, that is 231 by 16. Question 37 says that find the middle terms in the expansion of 2x square minus 1 upon x raised to the power 7. So here number of terms will be 8. Okay. So fourth and fifth terms will be the middle term. The fourth term is given by 7c3 2x square raised to the power 4 minus 1 upon x raised to the power 3, that is minus 560 x to the power 5. And fifth term is given by 7c4 2x square to the power 3 minus 1 upon x raised to the power 4, that is 280x square. Question 38 says that prove that the middle term in the expansion of x plus 1 upon x raised to the power 2n is 1.3.5 times up to 2n minus 1 divided by n factorial times 2 raised to the power m. So if you remember, we have computed this. Yep. So you look at this question 32 first. Okay. If you remember this particular expansion, it is same as this one, right? So power is 2n. Number of terms will be 2n plus 1. So middle term will be n plus 1th term, and that will be independent of x. And that is 2n factorial divided by n factorial times n factorial, which is equal to the given expression. Question 39 says that show that the quotient of the middle term of 1 plus x raised to the power 2n is equal to the sum of quotients of two middle terms in 1 plus x raised to the power 2n minus 1. So for the first one, the middle term would be n plus 1th term, that is 2n cn x raised to the power n. So quotient is 2n cn. Now 2n terms, the spelling is typo mistake is there. In the expansion of 1 plus x to the power 2n minus 1. So middle terms will be nth and n plus 1th term, and the quotient would be 2n minus 1 cn minus 1 and 2n minus 1 cn. Now we know that 2n minus 1 cn minus 1 plus 2n minus 1 cn is equal to 2n cn, and hence we have proven this. In question 40, we have to find the middle terms in the expansions. There are 5 expansions. The first one is 2x upon 3 minus 3y upon 2 raised to the power 20. So there will be 21 terms, and 11th term will be the middle term. So 11th term is given by 20c10 times 2x upon 3 raised to the power 21 minus 10 times minus 3y upon 2 raised to the power 10. That is equal to 20c10 x to the power 10 y to the power 10. Second expansion is 2x upon 3 minus 3 upon 2x raised to the power 6. So there will be 7th term, and 4th term will be middle term. Now you see this is symmetric. 2x minus 3 and minus 3 upon 2x. So these will cancel each other, and only the quotient would be what is there, and 2 and 3 will also be get cancelled. So 63, that is minus 20, would be the answer. Third question is x upon y minus y upon x raised to the power 7. So like previous one, this is also symmetric, but power is 7, so middle terms will be 4th and 5th. And 4th term would be 7c3 x upon y raised to the power 4 minus y upon x raised to the power 3, that is minus 35 x upon y. Now by symmetry, the quotient will be same, but powers will change, so it will become 35y upon x. Fourth one is 1 plus x raised to the power 2n. We have already computed its middle term, that is 2n factorial upon n factorial times n factorial x raised to the power n. Fifth one is 1 minus 2x plus x square raised to the power n, that is equal to 1 minus x raised to the power 2n. So we have already computed it. It would be minus 1. There is something this n should be outside the parenthesis. So the answer would be minus 1 to the power n to n factorial divided by n factorial times n factorial x raised to the power n. And with this, we come to the end of 40th set of fourth set of problems, that is question 31 to 40. And in the next video, we will solve question number 41 to 50. I could have solved more problems, but in previous video we had this question where we had 6 parts, 7 parts, or rather 8 parts. So we did only 5 problems, and this one we had 5 parts of this one. So again, we did only 5 problems. Let me show you my website. You can come to vastavakru.org. Yeah. So second, third, and fourth link are algebra, trigonometry, and coordinate geometry PDFs. You can download these books and add the date which is mentioned here to the downloaded PDF. I cannot put the date in the link or the file. The reason is that if I do that, then the existing links will become invalid when the date will change. So if you share the link with someone, this should remain valid for a long time, and that is why the actual files don't have link. You should revisit after 15 or 30 days to see if the links have changed, and if the date has changed, and if the date has changed, you can download again. Okay, now if you want to ask questions to me, you can come and click 8th link, which is kundika.astra.org. You can make a login here and ask questions here. How to this uses markdown, and to look at the markdown help, you can click at question mark in the editor itself, or you can come at this URL markdown help, and here you can see the syntax which you can use to ask the question. There are tags already created for you guys. You have algebra, calculus, geometry, coordinate geometry, probability, trigonometry as your tags. So, and mathematics is another tag. So you can make use of these tags to ask questions to me, and I'll be more than happy to answer your question. So thanks a lot for watching the video. I will take my leave here, and we will meet again tomorrow with 10 more problems on binomial theorems and expansion. So once again, thanks a lot for watching the video, and I'll see you in the next one. Enjoy.